Okay, so hello everyone. I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team and part of the answer team on AskTOM. It's my job to help you get the best out of Oracle database and hopefully have a little bit of fun while doing so. So with that in mind, I'm really excited today. This is the first SQL Office Hours session we're running. This is your chance to ask us live any questions you've got about SQL. And today we're going to be focusing on analytic SQL, analytic functions. So I'm really pleased to have with me today Keith Laker, who is the product manager for analytic SQL. Keith, can you just give us a quick hi?
Hello, everyone. Good to have everyone on the call today. Thanks for inviting me, Chris.
No worries. I say Keith's the product manager for some of the things we're going to be talking about today. I think pretty much all the stuff we're going to talk about today, probably. So, you know, he's ensures that we get good, powerful features in SQL. So he'll be hopefully be able to help us answer some questions as we go along. Before we get started, just some kind of general notes. I say this is a live Q&A session. We're going to be handling sessions in the chat window. So just put them in chat as we go along, as you've got them. Couple of things to bear in mind about questions. First up, we're not support here. So if you've got problems with SRs, then you need to contact support. So if you've got bugs, SRs, go to my Oracle support and handle it that way. Similarly, I'm not going to get into any discussions about pricing or licensing here. That is a question for your account manager. What we're here to do is help you understand and use the technology effectively, specifically SQL. When asking your questions, to help us it helps if you give us some background about why you're asking. If you just want to understand how the technology works for your knowledge, that's fine, that's great, that's good to know. But if there's a specific problem that you're trying to solve, you know, you've been asked to implement some requirement and that is why you're asking the question, please give us a bit of context, because that will help us answer the question more effectively and maybe come up with a different approach than the one you're specifically asking about. So context helps when asking the question. So we've had some people submit some questions in advance, and there's a few other kind of common questions that come up a lot when people are talking about analytic functions and analytic SQL. So what I'm going to do to start with is I'm going to go through a couple of common questions we get when dealing with these things. So first kind of question that we often get is people looking to find consecutive rows in their data. So they've got a series of numbers or a series of dates, and they want to find the rows that are consecutive, either so they can group together, count how many consecutive things they are, batch them up, whatever you want to do. So this is kind of like often the first pass in further analysis. So what we're going to do is look at a couple of ways we're going to solve this. And in order to do that, what I'm going to do is introduce something I like besides SQL is running. So New Year started, I made a resolution, I was going to start running some more. You know, I did it years ago and I'm going to get back in the theme of it. But I want to track how much I'm running. I'm recording every time I run, how far I ran and how long it took. So I get a log that looks something like this. So I've got all the dates down on the left and then how long it was and how far I went. What I want to do is see how often I'm kind of sticking with the program. I want to know how many days I consecutively went for a run. You know, am I sticking with my resolution or not? So if we got our data set here, we've got 4 groups of consecutive data like this. So we've got the first, second, third, and fourth. I want to then group them up to see how many days, you know, what's my longest chain of runs and that kind of thing. So how do we do this? Let's look at how we're going to do this with SQL. But before we do that, actually, before I dive into the SQL, let's kind of take a step back and ask, how do we know if rows are consecutive? How do you know if values in a data set are consecutive? And this might seem kind of a strange question to ask, but actually it's going to form the basis of our answers. So very simply, something is consecutive if the current value equals the previous value plus 1. So if we sorted it by date, my current run, the run I've just logged, is consecutive with the previous one if the difference between them is 1 day. So that marks something as consecutive or not. So how does that help us? What's that going to do? Well, now we can use a little bit of maths to kind of use this principle to group our data. Well, how does that help? Okay, what we're going to do is assign a row number to every row in our table. So this is just an incrementing value for each row. And notice that these are consecutive. The row numbers are consecutive. So the difference between every single value is 1. How does that help us? Well, what we can now do is, if we've got consecutive dates, the difference between the row number and the date will map to the same value. Okay, what does that mean? Well, if we subtract the row number from the date, when the dates are consecutive, they will map to the same value. So we can see we've got our 4 different groups here. Each of those gives a different value, or each group maps to the different value. And so now we've got this computed value. You can group by that, or use it to assign a row number, or whatever it is you want to do with this analysis. So, and this forms the basis of something that's called something I always struggle to say, the Thibodeaux method. So if you're curious about this and want to know a bit more, then this is kind of what you want to search for, the Thibodeaux method, as I trip over my tongue there. So let's look at how this actually works in SQL. How do we write our query to do this? So first thing we've got to do, we're selecting our run date, and then we're assigning a row number to every row. And we're trying to find it consecutively by date. So this goes in our order by here. So this gives an ascending number for every single date in our table. All we have to do then is subtract the real date from the row number to give our group. We can then stick this in a subquery, group by this computed column, select whatever other columns we want, and so on. So that's kind of one basic approach that we could use to find consecutive rows in our data set. And this has been around basically as long as row number has been around. So, since 8i, something like that. And of course, even before that, you could have gone with row num instead. However, as I said, there's a couple of approaches we can use. The second method I'm going to look at uses something we introduced in 12c. That's pattern matching. So this is a new clause we brought in called match recognize. And we can do the same kind of analysis on the data with this clause. So see how this works, kind of look at our data set again and remind ourselves what we're doing. So we know rows are consecutive if the current row equals the previous +1. So our 2nd of Jan is consecutive with the 1st of Jan. If we look at the 10th of January down here, the difference between that is 3. So those two are not consecutive. Or to put it a different way, this is not equal to the previous value +1. So we can now use this kind of formula we've got here, or this test we've got here, to find whether or not rows are consecutive. I'm doing something a little bit like this. So I'm going to gradually build up our match recognize clause here. And the very first thing I'm doing is defining how I know something is consecutive. So we say, if the run date, our current run date, equals prev. So this is a new function for match recognize that looks at the previous row in our data set +1. If they're the same, then we match this variable. We say that they are consecutive rows. Okay, so that's defined whether or not they're consecutive. Next thing we need to say is what the pattern we're looking for is. And we do that, we have this new pattern clause which goes above it. And we say, so start or start, as it, we can't use start because it's a reserved word, but we say start and consecutive star. And you're like, okay, well, what's going on here? Where's this start variable? We notice that it is undefined. We have not given a definition. We haven't said what this means. So therefore, it's always true. The first row we encounter in our data set will match this variable. It will check whether this is true. We then move to the next row in the data set and check whether it matches the condition for consecutive. So we test, is the run date for the second row, the 2nd of Jan, equal to the previous row plus 1, 1st of Jan? If it is, then we've matched this. Now, notice at the end here, we got the lovely little star. This is because pattern matching uses that thing developers all love, regular expressions. Okay, they're really powerful. You can do some really cool things with them, but they can take a bit of thinking to get your head around. But these form the basis of our patterns here. I'm going to keep it nice and simple for this demo here. All we're doing is saying we want 0 or more matches. So we matched our start, so that's any row, and then 0 more consecutive rows. Why 0 or more? Well, remember we had that row 10th of January, which was a kind of a group in itself. That has no consecutive values, so we do not match there. So what we're saying, everything else, we match our start, then we test the consecutive condition, and as long as the following rows match this condition here, so they're true, the previous value plus 1 equals the current value, and we continue to stay in the consecutive match, and we keep assigning it to the same group. As soon as we encounter a row where this is not true, so the difference is greater than 1, we start a new group and go back to the start pattern variable here. So that's kind of the beginning here. This is the basis of how we actually get going on this. There's still some more we need to do here with our clause though. And one of the things is we haven't yet defined how we're processing the data or which order we're processing the data. As it stands at the moment, we can be processing them in any old random order. We want to check the rows from oldest to newest. And in order to do that, we have to add an order by. So very strangely, at least to me, you can create a match recognize clause without an order by, which means that the data set or the order you process the data set is undefined. Even if it comes from a previous subquery, which is sorted, there is absolutely no guarantee that match recognize will process it in the order it came from that previous subquery. If you want to process the data in a particular order, which as far as I can see with match recognize you'd always want to do, I can't think of a situation where you wouldn't, then you need to have an order by. So just make sure you include that. So that's saying we're processing data from oldest to newest so that we can check whether the current row is equal to the previous plus 1. Then there's one last thing we need to do, or would like to do, I should say here, and that's add a measures clause. And the measures defines columns in your output. So match recognize sends the results up to the select clause, and we've defined some things we want to appear here. First up, match number, I should say. This is again a new function for match recognize. For each new group we encounter, it increments count. Increments counter. There's a bit duplicative there. And then count star works as the way as you would expect it were. How many rows did we match in this group? So we can see how many different values there are. So we can see there we had our 2 different approaches for managing this, finding consecutive rows in our data set. We had the old Thibodeaux SAN method and the new match recognize approach. Now, some of you might be thinking, well, okay, we got these 2 methods, which should I use, which is better? And to be honest, there isn't a huge, when it comes to functionality and performance, they kind of work out the same way. And as long as you're on 12C, you have to be on 12C to use match recognize. Which you use is kind of largely down to personal preference. But I think it is worth looking into using match recognize and see why. Let's look at a new use case. Yes, and of course, as Keith's reminding you, we can also use the model clause in 10G. As if you're feeling brave, you can go for the model clause. So there's various different ways you can go with this. But I'm going to move on to a new requirement, and that's rather than consecutive rows, I want to group the rows into 7-day batches. But there's a little extra detail I want to add to this. Each new group starts from whatever the date of the next row is. So if we go back to our data set here, I've got two groups of 7 days, according to this rule, because I want to start the second group on the 10th of January, not the 8th of January, which would be, if we just did it by calendar weeks, for example. So this is a critical point here. There can be an unknown gap between the end of one group and the start of the next. It might be that I went running on the 8th of January and that next group would start there. Or maybe I just got really slack and then didn't run again until 1st of February or something like that. So there's an unknown gap here, and this second group only starts, or the start date of the second group is whatever the value of that next row is. So we got two groups here. And basically, as I said, this is not with calendar weeks. So if we did this with calendar weeks, we'd end up with 3 groups, one from the 1st to the 7th of January, then 8th to the 14th, and then our final row at the bottom here jumps into a new calendar week. That is not what I want to happen here. I want all of these to group together into one group. So what we're going to do is look at ways we can do this. Now, one of the things people might be tempted to do is do something like this. You can truncate. IW returns the start of the ISO week, which is always a Monday. So it finds the Monday before the current date, or Monday if it is a Monday. And we can see that doesn't work because we ended up with the 15th of January down at the bottom here. I don't want that. I want the this second group to start on the 10th and continue through to the 17th. And this is now, there are ways you can do this prior to pattern matching. You can use the model clause, or you can use recursive with in 11.2. But I wanted to just show you how you would do this using match recognize. So let's just remind ourselves what it is we're trying to do here. We're trying to find rows where the current day is less than the first day of the group plus 7. So if the current day is less than whatever the start date of the group is plus 7, we are within that 7-day batch. If it's not, then we're going to start a new batch. Now notice this looked a little bit like that previous thing we had where we were trying to find consecutive rows. We're checking the current date with the previous one, but here we're going back to the first. So we can plug this formula in as well into match recognize, doing something like this. So we say our run date, and we've got this first function. So just like we had a previous, look back one row in the data set, first finds the initial value in the group. So whatever value that first row in the data set had, we match that. And then I've called it within 7 to kind of show that we're within 7 days. And then completing the clause like this looks very similar to that consecutive rows method we had. If you remember, we've got our start, our always true start to begin the group. We've got our within with our star, because we could have only one row in a particular group. And the rest of it looks very, very similar, right? Well, if we just kind of jump over to it, we can see that actually they're pretty much the same. Okay, I've renamed the variables for clarity, and I've changed, equals prev to less than first and 1 to 7. But actually, these are pretty much the same thing. Sorry, I'm going the wrong way. So this is one of the things why I'd encourage you to start looking at match recognize. It becomes really easy to change the pattern that you're looking for. You don't have to rename the variables, but I would for clarity. But you can change these conditions really easily and come up with new patterns in your data set. Whereas if you've got a classic analytic function style approach, either when the requirement changes like this, you've got to pretty much throw it away completely and start again, going for a completely new approach, or you'll have to substantially rework it. Whereas this, you're just kind of redefining a few pattern variables at the bottom. So this is why I can say that you really should start looking at match recognize as a way to do these kind of processing a set of data and looking how to group them, or finding changes in how it works, because it is then much easier to change your query if you've got updates in it. So, as I say, if you've got any questions on this or any other general questions that you'd like answered, then please put them in the chat window and we'll pick them up. I had one other quick question that I wanted to cover, and that's something someone else submitted beforehand. So they were saying they were getting this error. They're trying to log into, they'd installed Express Edition on their laptop, I believe, and they were trying to connect and running into this lovely error. And notice we got this 1034 Oracle not available error. And it's like, well, what does it mean? What's going on here? The problem here is very simple. Oracle the instance is not started. You cannot access the database because it's not running. So the solution's easy. You just need to start your database up. I'm not going to get into the details of exactly how you do that, because it depends on whether you're on Windows, Linux, so on, and how you configured. But basically, if you see this 1034 error, your database isn't running. You need to get it going. So now it's time. That's all I had kind of prepared here. So if you could start putting your questions in chat. If you don't want to show the wide world what they are, feel free to just put them to me privately. While we wait for some of those to come in, Keith, was there anything else you wanted to add on what we discussed there?
No, we have got a lot of pattern matching examples and analytic SQL examples on Live SQL. So, I mean, this is a great repository. It's full of really, really good stuff. And of course, you always get access to the very latest version of the Oracle database. So this is always a good resource.
Yes, that's a great point, Keith. I was just going to say, so you see, we can go into the code library here and type in match recognize. These first two scripts at the top actually just kind of go through what I've just been talking about. The 7-day batches also shows the two other solutions I didn't talk about, the model clause and recursive with. So if you want to play with those, familiarize yourself with those, have a look. And of course, you've got a whole stack of scripts in here, haven't you, Keith? So I believe these kind of things here are all yours, aren't they?
Yep. Most of those I think are mine.
Yes, cool. And I think it's also worth pointing out you've got a lot of detail on your blog here as well, haven't we? On you go into a whole lot of deep dive information about how match recognize works, which I think it's, as I say, it's one of those things. It's like it's mystery is only exceeded by its power. It is really cool. I really like it, but it has a lot of. It does take a little while to kind of get used to. I don't know if you've got anything to add to that, Keith. Or...
It's very quick and easy to get started, and because it's so quick and easy, I think it's easy to fall into the way of thinking that it'll do basic stuff for you. In reality, once you move into the documentation, you'll see that there's a wealth of parameters, of options for you to set that gives it an enormous amount of power. I'm almost tempted to say it's like the SQL model clause on steroids, but I know SQL model clause strikes terror into just about everyone's hearts. So I probably wouldn't align it with SQL model clause, but it is tremendously powerful.
Yeah, I think, like I say, a lot of people get a bit nervous about, worried over model clause. Personally, I find match recognize not only easier to understand and use than the model clause, but actually just more powerful generally. So I think, you know, I don't know if there's any particular problems you're aware of that model solves that match recognize doesn't, but I'm not aware. I can't think of any.
I can't. Well, SQL model clause does have, I'm going to say, a higher degree of flexibility to potentially create new rows, to insert new streams of data that didn't exist in the original input in whatever form, and maintain the same layout, the same columns, etc., as the original. So I think from that respect, it has the potential to be more powerful, but at the same time, it is a lot more restrictive. There are certain rules that you have to conform to, and its processing capabilities are not in the same league. I think we'd be extremely happy of you throwing billions upon billions of rows into a SQL pattern matching clause. SQL model clause might struggle a little bit on the performance side. It will get the job done, but it would be significantly slower, which I think sort of goes to this question which has come in on the forum, asking whatever way you write SQL, do you get pretty much the same performance? This is probably one of those cases where you could write a really nice, powerful SQL model clause and do the same in SQL pattern matching, and SQL pattern matching would win hands down. So yeah. I think that's probably a good example of using SQL in two different ways, getting the same answer, but the performance that you get is quite different.
Yeah, I think that's actually quite an interesting question that's come in. Is saying whatever way you want to write your SQL, they'll perform the same, and that's a lot of instances. It is true. Certainly, the Oracle Database Optimizer is very powerful now, very smart, can do all sorts of really neat things with your query. So when you submit it to the database, it will then look at that and go, actually, I can rewrite this in some completely other way. And so sometimes the query actually executes may look very different from the one you sent to the database, but it can't do that in all instances. And I think, as Keith says, switching between things like match, recognize, or the model clause, or a pure analytic function variation of a query is beyond what it can do. So it is not it's not true that whatever way you want to write your SQL, it will always perform the same. I mean, I know that was one of the goals of SQL, and if you're using kind of standard SQL, just like joining a few tables, selecting a few rows, maybe sorting and doing basic group by, that may be true. But as we start getting into this kind of analytic SQL, as Keith says, it's really not the case, unfortunately, or fortunately, depending on which way you look at it. So I don't know if you had anything else to say on that, Keith, or?
I don't know if I'm allowed to plug an 18C feature at this point.
Oh, I think, go on then.
So I think we certainly, from a development perspective, we understand that that's exactly what you want to do. You really want to be able to write a SQL statement and pretty much have it or have it access underneath the covers all of the features, the performance features that we put into the database. So a couple of years ago, I think in 12C Release 2, we put in-memory cursor duration temp tables in for situations where you were using the with clause. We would create an in-memory temp table for reusable results. Now, that all goes on transparently under the covers. You execute the SQL, we optimize it, and we introduce the performance enhancements in each release, and you just want your SQL to naturally inherit them. Where this can get a little challenging is where you need to stretch the power of the SQL functionality we put in the database by having your own algorithms. And typically those get implemented as table functions. So what you can do is in 18C, we are giving you something new called a polymorphic table function. And the good news about those is where you write table functions, we will treat them as first-class objects, which means as your SQL gets executed, we can introduce transparently all the performance benefits that we add into each release. So each release as you go forward, as we get up to 19 and 20 and so on, if you're writing polymorphic table functions to implement your own algorithms against SQL tables, relational tables, then we will be able to transparently inherit all of the performance enhancements going forward. So there's a greater opportunity there, if you like, for you to write the SQL that you need and for you to get the best performance possible via the database. And as soon as 18C is out, I did a presentation open world on this where we looked at polymorphic table functions and showed it transparently, picking up all of the latest 18C memory enhancements, performance enhancements that we added in. And as soon as 18C goes out the door, obviously I'll publish that presentation. You'll see the flexibility you can get and how that gives you the ability to pick up the enhancements that we put into the database without you natively having to code anything to get access to those performance improvements.
Well, that sounds really cool, Keith. I know quite a few people are excited about polymorphic table functions, so I'll have to see what they come and see what cool / crazy things people come out to do with those. So I think they have a lot of power, as you say. So there was a question which came in to me about the with clause, and they're asking what is the advantage of using this in the query in terms of performance and when to use with clause or not to use. So I think actually with the with clause, I find it more useful as a way to kind of logically break up your SQL statement. So if we kind of go, I'll just bring up my slide again quickly where I had the with clause, but what it enables you to do is name subqueries. So in the past, if you wanted to write, you had an inline view and you had another inline view and you're kind of nesting those, it could get really tricky to figure out where you were in your SQL statement. So you could end up getting more and more nested in these. So what I will do is actually, I'll just kind of go to here and look at, if we bring up my SQL developer, so if I do something like this, so in the past you could do something like this, and then you can have an inline view like this, and then you can nest it like that. And there's a couple of things with this. First of all, it gets really tricky to figure out what's actually going on in your SQL statement. If you're at this level here, how does that relate to what's going on here? And if you want to run just this bit, how do you know what to select? Sometimes it doesn't always work because you've got to select the right bits, make sure your brackets line up. The with clause enables you to kind of work from the inside out. So you've got this inner query. So you can say with inner as, select star from table. And then based on that, have another one. So next, I'm using all reserved words here. How am I doing that? So select star from inner and so on. And really, actually, I think the main benefit of it is to make your SQL easier to read, write, and understand. So I'm saying, okay, what do I want to do first? I want to get all the rows from my table and I want to group them by something or the other. Then once I've grouped them, I want to take the average of those, average, blah, 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 or, and I've got the average of the counts. So I've got some counts, and then I want to take my average of the counts like this. And then I want to do some other thing based on that. So as long as I've given these kind of meaningful names, it's then much easier to come back and understand what's going on. Also, if I want to debug it, I can just kind of go, okay, select star from inner, and it will only execute this part of the query. So I can really easily see as I'm going along, build up my SQL statement and figure out what's happening. So I think that's really the key benefit of the with clause. That said, there are some performance benefits to it as well. So if we've got a common subquery here, so let's say we're doing something like this. We've got, let's call this common. And then we go select star from T where X in select star from common. And Y is greater than select star from common, and so on. And I'm referring to this subquery multiple times. Oracle can actually optimize this and store the results of it. So it only calculates this once, and then particularly, if we're grouping millions of rows and get down to just a handful, as you quite often do, it's just then accessing a few rows. So it executes this once, and then you can get those the actual results that there. So that's potentially quite a useful performance benefit. There is a functional reason for using this as well. And if we jump over to live SQL, here it is, and we look at, go back up, one of the methods I didn't talk about, oh, my session's expired. So always annoying that, oh, come on. Okay, come on, live SQL, work with me. Leave it too long and it doesn't, so let's search for match recognize. There we go. And that's 7 batch 7. Maybe mine's the only one with 7 in. I'll have to log in, I guess. So, and if I go back in and go into my scripts, because then I'll know where it is exactly. And we can see in our 7-day batches approach, I talked about the match recognize solution. I said in 11.2 you could have a recursive with solution. So this is something we call recursive query subfactoring. It's looks a bit big and scary. I won't talk through this in detail right now. Have a look at it. Feel free to read up. Obviously, if you've got a specific question, then please say. But what this enables you to do is hierarchical queries. So up to 11.2, if you wanted to create a tree, so we have the classic employees hierarchy, you've got your CEO at the top, and then you've got his, the board and the other people who report to him, and then you've got your vice presidents, or whatever they're called in your company below them, and all the other underlings underneath that. So you've got your tree structure. Before 11.2, you would use connect by to do that. Recursive with is the kind of ANSI compliant way to do this, which came in 11.2. And in a lot of cases, you can do the same things with both of them. One of the nice things about recursive subquery factoring is it enables you to define whether you want depth first search, so you start at the top of the tree and then go all the way down to a leaf, or you want breadth first search, where you start at the top of the tree, go to the next level, and you just keep working along. So it enables you to kind of choose which of those approaches that you want to go for. So those are kind of key things to bear in mind with the with clause. So if you've let me know if that answers your question, that'd be great. Okay.
Yeah, the other thing to look at with the with clause, if you're on 12.2, excuse me, is if you look in your explain plan, you should see in-memory cursor duration temp tables kicking in, where you have reusable queries. We'll not only just execute the query once and store the results, we'll put it in memory so this doesn't require the in-memory option. You don't have to license any new features. But we will make use of in-memory data structures to store your results from the reusable select elements of the query. And that will give you a pretty big performance boost. And you'll see that in your explain plan. You'll see in-memory cursor duration temp table coming up as an explanation in your explain plan.
Okay, that's great. Thanks, Keith. Okay, so we'll just go back up. There was another question that came in, which came to me directly. Someone was asking about the rollback segment to small error, and so this is an interesting one. There's actually, you see Keith smiling about that. There's actually several things that can cause this, but actually it's the error, unless you're still running ATI, which I doubt I hope no one out there is running ATI. So in it was 9.9, wasn't it? We switched from rollback segments to the undo table space. So the undo table space is where Oracle saves kind of the history of what's going on. When you insert update rows, change data in your table, Oracle, to get a consistent view of the data, has to be able to kind of work backwards and say, how did the data look before you did that? So if Keith starts a query now, and it's going to run for 10 minutes, and then a couple of seconds later, I go and update the whole table, and I change all the rows. The data set for Keith's query is fixed at the point in time he runs it. But then I've just come in and changed everything. So Oracle needs a way to be able to kind of and say, okay, well, how did it look when Keith started his query? And that's when it's doing with the undo table space. Every time it encounters a row, if I've changed it, it'll then go, okay, well, I can see that Chris has changed it, but Keith needs how it looked before. So let's step back, undo, hence undo table space, what I've just done, and see what it was. Now, of course, the problem here is the undo table space is a fixed size. You've only got so much disk space, and potentially your DBAs have set it up so there's an upper limit on how big that actual file is. If it is a billion row table, Keith's running his query, I've updated all the rows. Not only that's a lot of changes to capture, and it's going to run for quite a while. At some point, the undo table space can run out of room, and we're not going to be able to keep going back and reconstruct that historical view. So that's kind of the key why you're going to get this. Oracle's trying to look back in the past, see how the data looked at some point in time in the past when you started your query. There's other possible ways you can hit this as well, but basically it's going, oh, I want that data as it was at T0, and it's now time, at 10 o'clock, and it's now 3 o'clock. I can't get that data because it's gone. It's been, I committed, we've lost that history, so that information is lost. So that's kind of the basic principle of that. So I don't know if you've got anything to add on that, Keith, or?
No, that's a pretty good summary, I think.
Okay, so let's have a look. A couple of other things that have come in. Would pattern match analytical function be the best option to identify overlapping or broken date sequences in a date register table where the start and end dates should not overlap and should have no gaps? Oh, that's it. Yeah. Multiple rows ordered by start date, and each following start date should not overlap the last end date, and there should be no gaps. So yes, identifying and looking for gaps in date ranges, that's an interesting problem, isn't it?
Yes, that sounds like one for referring to a Stu Ashton blog.
Yes.
Who's covered this?
I was going to say, this is, I think the short answer is yes, you can do these things, use matching, recognize, and there's various other ways you can do it. However, the precise details of how you do it is quite involved, because there's edge cases all over the place. You've got to make sure you test your conditions correctly. So rather than me try and explain exactly what you do, what I will do instead is point you to Ashton, this blog, and it's there we go, an Oracle plot programmer, SQL and PL SQL techniques by a guy called Stu Ashton. So He's one of our aces, and he's got a whole stack of a whole series of posts where he discusses this exactly. So if you want to, rather than us try and abstractly answer that, I think it's much better you go and read that and have a look through the information he's talked about there. Okay.
Yeah.
Okay, so let's see. So next up, are there any plans to make the with clause also available to non-select DML statements? That is, coding it at the top of the statement and not just inside subqueries appearing in the DML. So I guess in insert, update, delete. I'm not aware of any. I don't know if you know anything about that, Keith, or?
No, it's not something we've got on the table at the moment. I have to think long and hard about that because there are obvious implications.
Yes.
All over that.
Yeah. I mean, I think it's worth saying that you can actually already update and delete a subquery in specific cases. You know, if as long as the database can uniquely identify the rows that you are updating or deleting, you can have a subquery where you say update, join some tables and do that. But it's quite easy to get caught out doing that. And it's not so straightforward. But I think probably would really need to understand what they were trying to do by this, rather than a generic question, I guess. I don't know if you've got anything else to say, Keith.
No, I'm just. It would be useful to know what the use case, the actual business case is. But I'm also wondering. It sounds, just reading that, as if it's going to be quite complex use case. So therefore, I'm wondering if you probably are better off coding it in PL SQL or something, where you can pick up all of the necessary edge cases and so on, that would be extremely difficult to actually manage, capture, and deal with in a straightforward with clause.
Yeah, I think that's so polymorphic table functions is what you're saying. No, that's a select, isn't it, rather than insert, update, delete.
Well, you can actually with the polymorphic tables, you can insert new rows.
Okay.
So in theory, you can delete rows, but of course, we're not deleting at source.
Right.
You're processing but not returning.
Okay.
So
yes.
you're removing them from the result set. It's not a delete. It's more a remove or an addition of rows. And that is possible within a polymorphic. It's a long time since I looked at my presentation. I'm trying to think. A leaf type polymorphic table, I think, is what you would need at that point.
All right. Yeah. Okay. Actually, so there's a clarification come in. I guess so they've got subqueries in their update, and they just want to list the with clause right at the very top, rather than.
Okay.
Yeah.
Interesting. Yeah, I can see that.
Well, I guess the answer is we don't know of any plans to do this currently.
I've got no plans at the moment to introduce that. I suppose then the question would be if we could, because I'm right in saying on AskTOM you've got a feature request forum, haven't you? Where people vote. So that might be worth doing it that way. Is maybe if we put that to a vote, see how many people feel that would be a useful addition.
Yeah, I think that's a good general suggestion there. Actually, I'll just bring that up and just show people. So over on the community forums, we've got. Oh, that's not the one I wanted to go to. That's the. Here we go. So this is the one you'll know about, Keith. List tag with distinct
Yes.
option. Everyone, the thing everyone wants to hear. So as we can see, this is where you can add your suggestions. So things that you would like to see us include in the database. So new features, changes in functionality, basically, and you can put them in, and then people can come in and vote on them, and then the PM team will come in and review these and see which are appropriate to do, which have a good, we're going to give benefit to lots of people, and are feasible for us to do, because there are some popular suggestions which a lot of people would like, but are just unfortunately slightly difficult for us to or implement, at least in any quick time frame. So if there's something you would like to see, then I'd recommend you just kind of go to this database ideas forum, submit it there, and then we can gauge community support. If a lot of other people want it, that lends weight. It makes it more likely it's going to happen. Obviously, no promises, but so certainly, if it's if you submit it and nobody votes for it, it does make it quite unlikely that it would get voted. You can see we've got a few which is getting voted down. So yeah, be aware that not everyone may want to see exactly the same thing you do. Okay. Okay then. So let's see. We're getting towards the end. I think we've got a couple of one or two other things we'll approach before we finish up. Someone's mentioned to me privately with the with clause, you can also use it to access package variables. So to select a package variable within that, and that's potentially a useful way. So now you're not having to do kind of like the infamous overhead of the context switch from PL SQL to SQL every single time. So yeah, there's lots of neat little use cases for the with clause. And personally, I think if you've got lots of subqueries within one statement, I would pretty much always look at using it, just because it makes your queries much easier to understand. Okay. So also looking a bit further back, so someone's also tried to find out where the PL SQL tables are stored, where PL SQL tables are stored during bulk processing. Okay, so if you're doing bulk processing, so bulk collecting data into a PL SQL associative array, nested table, whatever, it's not physically stored. It is only in your memory. So it's in your session memory. It's in the PGA, so it's private to you. And that means once you're finished with it, it's gone. So if your session ends, that information is gone. And of course, if it's within the scope of a PL SQL procedure or block, once that block ends, it's gone. You can set it up as a package global variable to kind of persist it. But basically, if you've bulk collected data into a PL SQL array, it's only in the memory. If you need to store that, if you need to keep that data, you've actually got to insert it into a table somewhere. Otherwise, yeah, that information is gone. Okay, and I think just one last thing then I'll cover before we finish up. I know there's some other people have had some questions which we're not going to have time to address today, unfortunately. So these are going to be monthly sessions. So if we didn't get to your question this time, I'm sorry, but come back next time and we'll do our best there. But I'll do one last thing before we finish. Someone was asking a little bit about the where current of and select for update options. So select for update is where you run a query and you're marking your intent to change that data. So that means the rows affected by it are then locked for updates or deletes by anyone else. So let's say, and one of the reasons you would want to use this kind of thing is to to prevent lost updates. So let's say we've got a banking application and me and Keith are transferring money between each other. when I send the money to him, we've got to decrease the amount in my account by £10 or whatever it is, and increase Keith's by the same amount. So that's two separate rows. So we run two separate updates. Now, what can happen is between those two updates, someone else could come along and query that data or update, insert rows or whatever, and we end up miscounting the information. So by doing a select for update, no one else can change that data until I finish the transaction. So I select for update both those rows. They are then locked. No one else can change them until I commit or roll back. So what that means is if I decrease mine by 10 and increase Keith's by 10, that's what will happen at the end. If I don't do that, what could happen is I could decrease mine by 10. Someone else could come along and set both of ours to 100. Update the account total to 100. So now we've lost that update of 10 to mine, and then increased Keith's by an additional 10. So we've now lost £10 money. That's disappeared into the ether. Poof. So select for update stops other people doing this. That's a very brief description. It's probably better you read up on exactly this. The where current of clause relates to that is just as you are looping through a data set, it processes the current row that you're on. I don't know if you've got anything else to say on that, Keith, or?
Yeah, that's pretty good.
Okay, so like I say, thank you everyone for joining this. We hope you enjoyed it. More importantly, we hope you've learned something. These will be monthly sessions, so if you had a question we weren't able to get to it, please come back next time and come in. For now, we'd really appreciate it if you go back to the office hours session that you've just joined, and there'll be a little feedback box there, so you can let us know what you thought about the session, what we could do better, if there's any other things we can do to make this more useful for you. Like I say, we're here to make you more successful, or as successful as possible with Oracle database. So the more information you can give us about how we can make these more useful, put it in, let us know. We'd really like to hear that. Just to remind you, if you wanted to see the scripts from the stuff I talked about at the start, then you can go over to Live SQL, search for match recognize. You'll find these two, how to find consecutive rows and how to group rows in 7-day batches. You can also find Keith's great series going into a lot more detail about match recognize. Also, I can see you've got the PDF version of your book out as well, Keith, which is it's a good read. It's a good way to kind of get started. I'd thoroughly recommend you take a look at that. And there will be a record. We are recording this, but we will follow up later on the exact details how you get that. Just anything you want to find about these office hour sessions, come back here. So, anything else you want to say before we finish up, Keith? Or?
No, it's been a good session. Thanks to everyone for great questions. Thanks, Chris and Stephen, for setting all this up and inviting me. It's been very, very useful. Certainly for me.
Great. Okay, thank you all, and I hope to see you next time. Bye-bye.